Okay, so now we're gonna talk about the properties of liquids and solutions, and this is gonna be kind of different because the way we do the calculations for liquids is different, and the units that we use to describe the concentrations in the liquids and solutions is different. In gases we or vapor phase we use the partial pressure to represent the concentrations, but here we use something like mass fraction, mole fraction, volume fraction, and we will go through these in more details. But this video will focus on the vapor pressure because it's actually a very important concept to be understood. The vapor pressure is a physical properties like heat capacity, like viscosity, density, and all the physical properties of materials. It's a specific, or it's a property that is special for this material. So each liquid has its vapor pressure, and the vapor pressure is a function of temperature. But first, the vapor pressure it represents the pressure exerted by the liquid on the atmosphere. So what happens if we have like a cup of water, then there is a pressure that's exerted on the water by the atmospheric pressure. And this is a pressure that's acting on the liquid, and the liquid itself is exerting pressure on the atmosphere. And usually in the normal conditions for water, for instance, the pressure exerted by the atmosphere is very high compared to the pressure exerted by the liquid on the atmosphere, and that's why the liquid is liquid in the room temperature. And this pressure that the liquid exerts on the atmosphere increases as the temperature increases. And this is what we see here. This is the relation between the vapor pressure in torr, which is the millimeter mercury. So 1 atmosphere is 760 millimeter mercury, or 760 torrs, and the temperature in the x-axis. And as we see, there are many lines here. Each line represents a liquid. This is the diethyl ether, this is ethyl alcohol, this is water, this is ethylene glycol. And as we see, in all the cases, as the temperature increases, the vapor pressure increases. And this is the case in any liquid. And as we see, the temperature at which the vapor pressure equals 1 atmosphere is highlighted here. So it's 34.6 Celsius for diethyl ether, it's 78.3 Celsius for ethyl alcohol, and for water, it's 100 Celsius. And this is actually a very important thing. That or first, the relation between the vapor pressure and temperature is expressed by many equations, and this is one of them. This is the ln of the vapor pressure equals constant A, which is specific for the liquid, minus delta H, which is the latent heat of vaporization, divided by RT. There are other equations like Antoine's equation. There are many equations that are used to calculate the vapor pressure. But in all the cases, you see that as the temperature increases, the vapor pressure increases. So it's the same thing. And back to the point that we were discussing before the equation, you'd see that these numbers are the boiling points, which is the normal boiling point. And from this we can understand that again, back to the pressure thing. As the pressure exerted by the liquid increases by the temperature, because the temperature increases, vapor pressure increases. So it's doing or pushing more pressure on the atmosphere. So it's like two pushing on different directions. The atmosphere is pushing the liquid to stay in the liquid phase, and the vapor pressure is pushing the atmosphere so that the liquid can evaporate. So once the vapor pressure reaches the atmospheric pressure, then the two forces are equal, and then the liquid can evaporate. And this is the reason why water evaporates at 100 Celsius, because of this thing. Because at 100 Celsius, the vapor pressure equals the total pressure. And from this, we can understand some more things. There are some special types of cooking. I don't know, the pans or pots, and these cooking pots are well sealed, so they have a cover, and it's perfectly closed and sealed. And it is designed this way so that when water inside the pot evaporates, it's trapped inside, so it increases the pressure inside the pot. And in this case, the water will evaporate at higher pressure because the pressure, the outside pressure exerted on the liquid is not 760. It might be 100, 800, 900, 1000. In this case, water needs to go into higher temperature so that it can evaporate. And these pots are designed this way because sometimes you have something that needs to be cooked at higher temperature so that it can be cooked well, um, which is not going to be achieved at the 100 Celsius. So it can reach 120 Celsius, 130 Celsius, because of the increase of the outside pressure. The other way that you can achieve the evaporation at lower temperature by decreasing the outside pressure. Uh, Again, just to make it clear, think of this as two forces acting on each other. The water will evaporate when its force will be more than the force exerted by the atmosphere. So either you increase the temperature of water so that this atmospheric pressure is constant, and you are increasing the pressure, increasing the vapor pressure by increasing temperature until you reach the point when the vapor pressure equals the outside the external pressure, so the evaporation will happen. In this case, we will have the temperature of liquid constant, and the pressure, which is the atmospheric pressure, is here, and you are reducing the pressure. So instead of increasing the temperature, you are reducing the outside pressure, so both will again be equal, and once they are equal, you will achieve the evaporation. So in this video, this guy is describing this process in detail. Okay, so this is exactly what I was saying, and it's nice to see that water is evaporating, and it was nice to see that this evaporation takes place. It's exactly what you see when you put water on the oven and or on the stove, and it's evaporating. So it's the same thing. Again, this confirms the concept that we were discussing before the video, that either you increase the temperature so that the vapor pressure equals the external pressure, or you reduce the external pressure so that the external pressure reaches the vapor pressure. So this is all for this video, and we're gonna continue in the next video. So, see you then.